What is the difference between a process and a thread?
A process is an independent program running in memory. Every process has its own memory space, resources, and execution environment. A thread is a lightweight unit of execution inside a process. Multiple threads share the same memory and resources of the process. For example, Google Chrome is one process, but each browser tab may run in a separate thread. Because threads share memory, communication between them is faster than communication between processes. However, shared memory also introduces synchronization challenges.
What is multi-threading in Java?
Multi-threading means executing multiple threads simultaneously within the same application. Instead of waiting for one task to finish before starting another, multiple tasks run concurrently. For example, in a music application, one thread plays the song. Another thread downloads the next song. A third thread updates the user interface. This improves responsiveness and better utilizes CPU resources.
Why do we use multi-threading?
Multi-threading is mainly used to improve application performance and user experience. Benefits include better CPU utilization, faster execution of independent tasks, responsive applications, background processing without blocking the main thread. For example, while uploading a file, the user can still continue using the application.
What are the different ways to create a thread in Java?
There are mainly two traditional ways. First, extend the thread class. Second, implement the runnable interface. Nowadays, using executor service is the preferred approach because it manages thread creation efficiently. In modern Java applications, runnable with executor service is considered the best practice.
Which is better, extending thread or implementing runnable?
Implementing runnable is generally preferred. A class can implement runnable and still extend another class because Java supports only single inheritance. It also separates the task from the thread that executes it. This makes the code more reusable, maintainable, and flexible.
What is the life cycle of a thread?
A thread goes through several states: new, runnable, running, blocked or waiting, timed waiting, terminated. For example, after creating a thread, it enters the new state. Calling start moves it to runnable. When CPU schedules it, it starts running. If it waits for a lock or another thread, it enters waiting. After completing execution, it reaches the terminated state.
What is the difference between start and run?
Calling start creates a new thread and internally invokes run. Calling run directly does not create a new thread. It simply executes like a normal method. This is one of the most common interview questions. Always call start to execute a task in a separate thread.
Can we start the same thread twice?
No, a thread can be started only once. If start is called again on the same thread object, Java throws illegal thread state exception. To execute the task again, create a new thread object.
What happens if run throws an exception?
If the exception is not handled, the thread terminates immediately. Other threads continue running normally. Only that particular thread stops. To avoid unexpected termination, exceptions should be handled inside the run method.
What is thread scheduler?
The thread scheduler is part of the JVM. It decides which thread gets CPU time. The scheduling algorithm depends on the operating system. Therefore, the execution order of threads is never guaranteed. Developers should never write logic assuming a fixed execution sequence.
What is thread priority?
Every thread has a priority between 1 and 10. Min priority is 1. Norm priority is 5. Max priority is 10. Higher priority only suggests that a thread should get CPU earlier. It does not guarantee execution before lower priority threads.
Does thread priority guarantee execution order?
No, priority is only a hint to the scheduler. Different operating systems handle priorities differently. Therefore, two threads with different priorities may still execute in any order. Never depend on priority for application logic.
What is thread sleep?
Thread sleep pauses the currently executing thread for a specified time. During sleep, the thread does not consume CPU. After the sleep duration ends, the thread becomes runnable again. Sleep never releases synchronized locks.
What is thread yield?
Yield tells the scheduler that the current thread is willing to give other threads a chance to execute. It is only a suggestion. The scheduler may ignore it. Therefore, its behavior is platform dependent.
What is join?
Join makes one thread wait until another thread completes. For example, the main thread waits for a worker thread to finish before printing the final result. Join is commonly used when one task depends on another.
What is daemon thread?
Daemon threads run in the background to support user threads. Examples include garbage collection and monitoring services. When all user threads finish, JVM automatically terminates daemon threads.
What is user thread?
User threads perform the actual application work. The JVM keeps running as long as at least one user thread is alive. The application exits only after all user threads complete.
What is synchronization?
Synchronization controls access to shared resources. It ensures that only one thread executes a critical section at a time. This prevents inconsistent data and race conditions.
Why is synchronization needed?
Without synchronization, multiple threads may modify shared data simultaneously. This can produce incorrect results. For example, two threads updating the same bank balance may overwrite each other's changes. Synchronization prevents such problems.
What is a race condition?
A race condition occurs when multiple threads access shared data simultaneously, and the final result depends on execution timing. Race conditions are difficult to reproduce because they may happen only under specific timing conditions. Proper synchronization eliminates race conditions.
What is a critical section?
A critical section is the part of code where shared resources are accessed. Only one thread should execute this section at a time. This is usually protected using synchronized blocks or locks.
What is the synchronized keyword?
The synchronized keyword ensures that only one thread can execute a synchronized method or block at a time for the same object. It provides thread safety by acquiring an intrinsic lock.
Difference between synchronized method and synchronized block.
A synchronized method locks the entire method. A synchronized block locks only the specified block of code. Synchronized blocks provide better performance because they reduce the locked area.
What object is locked in a synchronized instance method?
The current object, represented by this, is locked. If multiple threads use the same object, only one thread can execute synchronized methods at a time.
What object is locked in a synchronized static method?
The class object is locked. This means all instances of that class share the same lock for static synchronized methods. Therefore, only one thread can execute any static synchronized method at a time.
What is deadlock?
Deadlock happens when two or more threads wait forever for each other to release locks. Since each thread is waiting, none of them can continue. The application appears to be stuck.
How can deadlock be avoided?
Always acquire locks in the same order. Keep synchronized blocks as small as possible. Avoid nested locking whenever possible. Use timeout-based locking if available.
What is live lock?
In live lock, threads are active but cannot make progress. Instead of waiting, they continuously respond to each other. The application keeps running, but useful work never completes.
What is starvation?
Starvation occurs when a thread never gets CPU time because other threads continuously get preference. The thread remains ready but rarely executes.
What is thread safety?
Thread safety means an object behaves correctly even when multiple threads access it simultaneously. Thread-safe classes protect shared data from corruption. Synchronization and immutable objects help achieve thread safety.
What is volatile?
The volatile keyword ensures that every thread reads the latest value of a variable directly from main memory. It guarantees visibility, but not atomicity.
Can volatile replace synchronized?
Number volatile only guarantees visibility. It does not protect multiple operations like increment. For compound operations, synchronization or locks are still required.
What is atomicity?
Atomicity means an operation is completed entirely or not at all. No other thread can see an incomplete state. Atomic integer provides atomic increment operations.
What is visibility?
Visibility means changes made by one thread become visible to other threads. Volatile, synchronized, and locks all provide visibility guarantees.
What is happens before relationship?
The happens before relationship defines when one thread is guaranteed to see changes made by another thread. Synchronization, volatile variables, and thread start or join establish this relationship.
What is reentrant lock?
Reentrant lock is an advanced locking mechanism. It provides features like fairness, trilock, interruptible locking, and timed locking. It offers more flexibility than synchronized.
What is trilock?
Trilock attempts to acquire a lock immediately. If the lock is available, it returns true. Otherwise, it returns false instead of waiting. This helps avoid deadlocks.
What is read-write lock?
Read-write lock allows multiple readers simultaneously. However, only one writer can modify data at a time. This improves performance for read-heavy applications.
What is atomic integer?
Atomic integer provides thread-safe integer operations without using synchronized. Methods like increment and get perform atomic updates efficiently.
What is thread local?
Thread local provides a separate copy of a variable for each thread. Changes made by one thread are not visible to other threads. It is commonly used for user sessions and database connections.
What is executor service?
Executor service manages a pool of reusable threads. Instead of creating threads manually, tasks are submitted to the executor. This improves performance and simplifies thread management.
Why is thread pool better than creating threads manually?
Creating threads is expensive. Thread pools reuse existing threads. This reduces memory usage, improves performance, and limits excessive thread creation.
What is callable?
Callable is similar to runnable. The difference is that callable can return a value and throw checked exceptions. Runnable cannot.
What is future?
Future represents the result of an asynchronous task. It allows checking whether the task is complete and retrieving the result later using get.
Difference between runnable and callable.
Runnable does not return any result and cannot throw checked exceptions. Callable returns a value and can throw checked exceptions. Callable is usually used with executor service.
What is countdown latch?
Countdown latch allows one or more threads to wait until a set of tasks completes. Each completed task decreases the counter. When the counter reaches 0, waiting threads continue execution.
What is cyclic barrier?
Cyclic barrier allows multiple threads to wait until all threads reach the same point. After everyone arrives, all threads continue together. Unlike countdown latch, it can be reused.
What is semaphore?
Semaphore controls how many threads can access a resource simultaneously. For example, if only 5 database connections are available, a semaphore ensures that only 5 threads use them at the same time.
What is the difference between wait and sleep?
Sleep belongs to the thread class. Wait belongs to the object class. Sleep pauses execution but does not release the lock. Wait releases the lock and waits until another thread calls notify or notify all. Wait must always be called inside a synchronized block or synchronized method.
Which multi-threading concepts are most frequently asked in interviews?
The most commonly asked topics are difference between process and thread, start versus run, sleep versus wait, synchronization, volatile keyword, deadlock, race condition, thread safety, executor service, runnable versus callable, future, countdown latch, semaphore, thread pool.